Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everyone. Okay, so for today we are going to proceed with probability distribution under the subtopic binomial distribution. Okay, so let's look at our objective for today's lesson. So in the end of the lesson, you should be able to define the binomial distribution, determine the probability of an event for binomial distribution, determine and explain the value of mean, variance and standard deviation for binomial distribution, and you are going to solve problems involving binomial distribution. Okay, so first of all, let's look at these events. What is the outcome that you think might be for this case? Okay, so what are the outcomes for the result of a match of a basketball game? Okay, basically, you know that every match it can only lead to 3 possible outcomes, which are you might be win, you might lose, or you might have a draw. So these are the possible outcomes for this game. Okay, how about throwing a dice? When you throw a dice, what are the possible outcomes that you will have? You can only have these 6 possible outcomes, whether you get 1, 2, 3, 4, 5, or 6. So these are the sets of the possible outcomes when you throw a dice. How about tossing a coin? Remember that in tossing a coin, you can only have 2 possible outcomes, whether you are going to get head or you get tail. We can never get both. Okay, we can never get both. We can only get head or tail. Same goes to gender of a baby. When we talk about gender, we know that we can only have 2 gender, female or male. So the events for gender of a baby, the possible outcomes might be either you have male or a female baby. Okay, so as we look at these examples, we can see that some example might have 3 or more possible outcomes, but some example it leads only 2 outcomes, and the outcomes must be only that possible outcomes. Like tossing a coin, you can only have head or tail. Like gender, we can only have male or female. We cannot have both head and tail. Or if I say about marital status, okay, marital status, okay, we can only have single or married. Okay, whether you are a widower, a divorcee, in this marital status, you can only state single. We state only single. Okay, we don't state. I don't think people state divorcee. We state single. That's why we call single parent. Okay, like if you have exam. Okay, you have exam. What are the possible outcomes? Whether you pass or you fail. You have interview. Whether you pass or you fail. So only those 2 possible outcomes. So this kind of outcomes, okay, this kind of 2 possible outcomes, okay, what can we say about the event? The event which leads to these 2 possible outcomes, so we call it as Bernoulli trials. So what are Bernoulli trials? Bernoulli trials states that there are only 2 possible outcomes, namely success and failure. So let's say, example, toss a coin twice. Let's say. So let's say, what are the possible outcomes that we are going to get head? Okay, head. So head in this case is considered as success. Okay, head as success. And tail is a failure. Okay, next. The chances of success are always the same in the trial. So let's say twice. Okay, so if we draw the tree diagram, we have this head, this tail, and then of course the second one will be like this, head, tail, like this, right? Okay, so what is the probability of getting head? Of course, 0.5, 1 over 2, because we have two possible outcomes, whether we get head or tail. So getting head is 1 over 2. So this is half in the first toss. The second toss, of course, probability of getting head is still half. Same goes to tail. So this is what we call this, the chances of success are always the same in the trial. Okay, next. If the probability of success is given by P, then the probability of failure is given by 1 minus P. Okay, in which basically we consider it as Q. In which probability must be greater than 0 but must be less than 1. Okay, this is important. Okay, next. The discrete random variable x equals to 0, 1, where 0 represents failure and 1 represents success. So, when we talk about toss a coin twice, okay, so in toss a coin twice, so we said that the x must be 0, 1 and 2. This is for toss a coin once, this is for toss a coin once. But when we talk about toss a coin twice, so x must be equals to 0, 1, 2. So what does x equals to 0 means? It means that getting no head in both toss, in both trials, okay? X equals to 1. Getting head once from the two tossing. Okay, x equals to 2. Getting head twice from the two trials. So basically this is what we call getting no head, so we get tail and tail. Getting head once, so whether we get head and tail or tail and head, and getting head twice is getting head, head. Okay, so this is what we've learned in probability in mathematics. Okay, next. What can we say about experiment of binary trials for a certain number of trials? So we did the experiment in binary trials for several times. So this is lead to binomial distribution. So a binomial random variable is the number of success R from n similar binary trials in a binomial experiment. Okay. Okay, this one already. Okay, so next. Okay, the probability distribution of a binomial random variable is known as a binomial distribution. Okay, probability distribution of a binomial random variable is known as a binomial distribution. Okay, next. Okay, how can we represent it mathematically? So x is called random discrete variables. X is binomial distribution, in which in this bracket is n and p, in which n is number of experiment and p is probability of success. Okay, x is binomial distribution in which number of experiment, p is probability of success. Okay, next. Okay, probability of an event for binomial distribution. How can we find the probability of event for binomial distribution? So this is the formula. P x equals to R is equals to the product of NCR P to the power of R Q to the power of n minus R, in which R must be positive integers. Okay, must be positive integers. So what does RPQ represent? So P represent the probability, X is the binomial random variables, R is number of success, N is number of trials, P is the probability of success, in which P must be greater than 0 and less than 1, and Q is the probability of failure, in which how can we find Q? Q is equals to 1 minus P. So this is the formula in getting the probability. Okay. Okay, tip. The event of getting a success or a failure is a mutually exclusive event. So I'm sure mutually exclusive event you have learned in probability. Okay, next. Let's explore. So let's say we have a triangular pyramid with 4 flat surfaces of equal size are labeled with a number from 1 to 4. Irfan flips the triangular pyramid 3 times. What is the probability of the pyramid sitting on number 4 after each flip? So 3 times. Okay, 3 times, that means number of trials. Okay, number of trial is 3. Okay, so apa kita punya R? What is R? R is apa? R is number of success. So what is our success? Okay, what is our success sekarang yang kita nak ni? Our success should be sitting on number 4. Okay, sitting on number 4. Okay, let's look more. Okay, first of all, we need to define X. What is our X? So X represent a random variable for the number of times the pyramid sits on number 4. So basically, X, number of times the pyramid sits on number 4. So, what does X equals to 0 means? What does X equals to 1? X equals to 2? X equals to 3? So, X equals to 0 means not getting number 4. X equals to 1, getting number 4 once. X equals to 2, getting number 4 twice. X equals to 3, getting number 4 thrice. Okay, so you need to understand what does it mean. Okay, next. P is the probability of getting number 4 after flipping the pyramid. So, what is P? P is actually 1 over 4, in which 0.25. Remember, when we learn about probability of an event is n of A over n of S, in which our event is getting number 4. So, in one flip, what is the probability of getting number 4? Of course, 1 from 4 possible outcomes, because we have number 1, number 2, number 3, and number 4. So, number 4 is 1 from all of the possible outcomes. So, that is why 1 over 4. So, how about Q? Okay, Q is the probability of not getting number 4 after flipping the pyramid. So, we know that Q is the complement of P. So, Q is actually 1 minus P. So, basically, Q is 0.75. Or, we can say that Q is 3 over 4. Why 3? Because this 3 comes from number 2, number 1, and number 3. Okay. Likewise, P tadi. So, P only number 4. Okay. So, that is why Q is equal to 0.75. Okay, next. Okay, if X represent the number of times getting number 4, so let G becoming the outcome of the pyramid sitting on number 4 and H the outcome of the pyramid not sitting on number 4. So, if we draw the tree diagram, we will have this diagram. Okay, in which G, okay, why does 0.25? Because G is getting number 4. So, before we state that P is equal to 0.25. And then we state that Q is equal to 0.75. Okay. So H represent for number 1, 2, and 3. And G represent for number 4. So the first toss, if we get G or we get number 4, we will have our probability is 0.25. How about second toss? Okay, second toss, see, you can see here, the probability in all of the tosses, the probability of getting G and H is equal. Okay, so what does 3 means? Okay, like X equals to R. So what does X equals to 3 means? That means that, it means that getting number 4 in all of the 3 tosses. Okay, so the same goes to GGH. We can see that we have G only twice. So X equals to 2 means that we get twice. We get 2 number 4 in 3 flips. Okay, same goes to the other. Okay, so in probability, we've learned that in order for us to find the value of probability, let's say GGG, so we said that the probability of getting all number 4, so 0.25 times 0.25 times 0.25. Same goes to HGH. So HGH means we've got only one number 4. Okay, so same goes to this. How can we find the probability? So 0.75 times 0.25 times 0.75. So this is when P X equals to R. Okay, so this is just revise. You revise on your knowledge in probability. Okay, next. Okay, so from here, from the diagram, we can say that, okay, this is from your knowledge on probability, probability in mathematics. So when we have none of the flips getting number 4, so we will have 0.75. Okay, so this comes from 0.75 times 0.75 times 0.75. So we will have 0.75 cube. Okay, this one. Okay, so how can we find this term? Okay, this kind of term. So it comes from G 0.25 times 0.75 times 0.75 plus 0.75 times 0.25 times 0.75 plus, okay, 0.75, 0.75, 0.25. So this is why, okay, why 3? Because we have 3 possible outcomes. Okay, so as we look at these 3 terms, all of the terms we have 0.75 twice. So that is why 0.75 to the power of 2 and 0.25 to the power of 1. So we have our value is 0.4219. Okay, but from the binomial distribution formula, we said that Px equals to R is the multiplication of the product of NCR, P to the power of R, Q to the power of N minus R. Okay, so 3C0 times 0.25 to the power of 0 and then times 0.75 to the power of 3. Okay, so we have our value is 0.4219. So as you can see, Px equals to 0 from the manual calculation with the formula, binomial formula, the answer is the same. So what does it mean by 3CO or 3C1 or 3C2? Okay, so it means that, okay, let's look at this tip. Okay, 7C4, okay, look at this example. The example in 7 days, 4 days are chosen. Okay, 7C4 means that in 7 days, okay, only 4 days, okay, only 7C4 means in 7 days, only 4 days. Okay, so let's look. 0.45 is the probability of success. 4 times the probability of success. Okay, that means 0.45 to the power of 4. 0.55 to the power of 3 means 3 times the probability of failure. So, in this case, we know that our R represent getting number 4. So, what does 3C1 means? 3C1 means from 3 flip, only once we get 0.25, right? 0.25 means getting number 4. So from 3 flips, only one we get number 4. So that is why 0.25 times 1. And then the other 2 flip, we get not number 4 again. So that's why 0.75 to the power of 2. So same goes to 3C2. Okay, Px equals to 2, because we said that 3C2 is actually Px equals to 2. Px equals to 2 we defined before what? We defined that getting number 4 twice. So 3C2 means from 3 flips we get 2 times number 4. That is why 0.25 to the power of 2. And the other one, 0.75 to the power of 1, means that we get only one number exclude number 4. Okay, understand? Okay, easy, right? Okay, next. Okay, note that the two methods, namely using a tree diagram and using the binomial distribution formula, yield the same probability values for each of the values of the binomial random variable x. Okay, we have proved that both methods leads to the same example. Okay, however, the tree diagram will be difficult to draw once the number of flips exceeds 3. So that is why we use the binomial distribution formula. We use this one. Okay, that is why, because if we have more than 3, it will be messy and hard work. Okay. Okay, so let's look at this. The probability of the pyramid sitting on the number 4 less than 2 times. Okay, less than 2 times means, okay, what does less than 2 times mean? Okay, can we choose the number which is bigger than 2? Of course, less than 2. So we cannot have number bigger than 2. So what number includes less than 2? Of course, number 0 and number 1. So the probability when x less than 2, remember x represent what? X refer to number of times getting number 4. Okay, so Px less than 2 is actually the probability when we get x equals to 0 plus, because x equals to 0, and the probability of x equals to 1. So what does x equals to 1 means before? So x equals to 1 means that getting number 4 once. X equals to 0, not getting number 4. So Px less than 2 is actually Px equals to 0 plus Px equals to 1. So we have the value here. So we just add up. So we have our probability of, when the probability we have 0.8438 is the probability of getting number 4 less than 2 times. Okay, so let's look the next one. The probability of the pyramid sitting on number 4 more than 0 times. So more than 0 times, of course, Px greater than 0. So remember, we flip it 3 times. So if greater than 0, of course, when x equals to 1, x equals to 2, and x equals to 3. Okay, so you can just add up. When Px equals to 1, 0.4219, x equals to 2, 0.1406, x equals to 3, 0.0156, we will have 0.5781. Or, if you are clever enough, you can say that, oh, x equals to 1, x equals to 2, x equals to 3, the complement for it is x equals to 0. So we understood that the total probability is equals to 1. So of course, the value for x equals to 1, x equals to 2, x equals to 3, when we add up all the probabilities, will be the same as if we minus 1 with probability x equals to 0, right? The complement of it. So we just use the value of p x equals to 0 because it's easier. Okay, it's easier compared to if we need to find all the values of x equals to 1, x equals to 2, x equals to 3. So the answer should be also the same, which is 0.5781. Okay, so from here we can say that all the probabilities involved, if we add up, it will lead to 1. So it fulfills that our probability must be greater than 0 but not bigger than 1. So the total probability should be equals to 1. Okay, let's look at example 1. Okay, so Ronaldo has taken 3 shots in an archery practice. The probability that Ronaldo strikes the target is 0.6. X represent the number of times Ronaldo strikes the target. A. List the elements of binomial distribution random variable. Okay. B. Find the probability that Ronaldo strikes the target exactly 3 times and at least 1 time. So exactly 3 times means that x must be equals to 3. At least 1 times. What does at least 1 times mean? At least, in Malay, we said that sekurang-kurangnya. At least, sekurang-kurangnya. So when we talk about at least, sekurang-kurangnya, what number must involve? Does the number must be involved greater than certain number or less than certain number? Let's say at least 1 time. So we know that, okay, it involves inequalities here. So this one. Should it be greater than 1 or less than 1? Sekurang-kurangnya. Of course, it should lead to number greater than 1. Let's say 1. Can 1 be included in this case? Sekurang-kurangnya 1. At least 1. Sekurang-kurangnya 1. Does 1 included in this case? Of course. 1 also can be included. So the number should be greater than 1 and also equal to 1. So what inequalities here? The inequalities involved is greater than or equal to 1. Okay. So let's look at A. Okay. So first of all, you need to define what is X. So X represents the number of times Ronaldo strikes the target. Okay. And number of trials. So sebab dia kata it states that taken 3 shots. So this is our N. Okay. Next. P. Probability of striking the target. Okay. Because it states that Ronaldo strikes the target 0.6. Okay. So list. How can we list the element of this binomial distribution? So this is how we represent the element. Okay. So X is a binomial distribution in which N and P. So we have our values of N and P. So just substitute. So this is our answer for A. Okay. So next. Let's look at B. Okay, B really. So we have said that, okay, this one refers to P, X equals to 1. And then this one refers to P, X greater than or equals to 1 because this is at least. So when at least, we need to consider number greater than 1 and number equal to 1. Okay, so next. Okay, define. First and foremost, of course, you need to define X. Only then you know what are you trying to get, what are you trying to find. So X is number of times Ronaldo strikes the target, N is equals to 3. So P, probability of striking the target, 0.6. And Q is the complement of it. So Q is probability not striking the target, so which is 0.5. 4. So we know that in order for us to find the probability, we need to use this formula. Px equals to R is equals to the product of NCR p to the power of RQ to the power of n minus R. So B1, since we said that, oh sorry, this is not 1, this is 3 times, sorry, x equals to 3. Okay, so when Px equals to 3, so 3C3 times 0.6 to the power of 3 times 0.4 to the power of 0 actually. So what does 3C3 means? Since exactly 3 times, so it means that from 3 strikes, we get 3. From 3 shots, we get 3 strikes. Okay, so this is what it means. So the answer would be 0.2160. Okay, how about B2? Okay, B2. So when we talk about x greater than or equals to 1, okay, remember our n is 3. So what are the numbers included in x greater than or equals to 1? Of course, we said that this number, when x equals to 1, x equals to 2, and x equals to 3, right? Okay, so this is our probability. We add all of this, all of the possible outcomes. When x equals to 1, it strikes once. When x equals to 2, we have 2 strikes. And x equals to 3, we have 3 strikes from 3 shots. So add up all of the possible outcomes, and then we have 0.9360. Okay, remember, when we talk about at least 1 times, okay, when it hit 1 times, so at least, that means that the number that not included is x equals to 0, kan? The number that not included in this case, which is at least, is x equals to 0. So we can say that, oh, that is alternative method in which we can consider the complement situation. Okay, so we can say that, oh, instead of doing this type of solution, I can also make it as this one. Okay, Px greater than or equals to 0 is also equals to 1 minus Px equals to 0, because this is not included in x greater than or equals to 1. So the answer will still become the same. So we have 2 methods. Okay, first the methods direct meaning, and the second one is the contradiction of it. Okay. Okay, example 2. 40% of the application for the Mara scholarship are not accepted. Okay, 40% not accepted. In a school, 7 students. So 7 students apply for Mara. So from here we know that n equals to 7. Calculate the probability that exactly 3 applications are not accepted. Okay, so from here we know x equals to 3. B, at least, again, at least. When we talk about at least, we are talking about greater than or equal. At least 2, so we are talking about greater than or equals of 2. So first of all, we need to define what is our x. Okay, so our x defined as number of scholarship application that are not accepted. Okay, and then we know that our n is 7, number of students applied, and then p is the probability of not being accepted, 40%, in which it is 0.4, and our q is probability of being accepted, so q is equals to 0.6. So let's look at A. So first of all, we know this is binomial distribution, okay, in which our n is 7 and our p is 0.4. since we are talking about finding probability, so we need to use this formula. Okay, so A, exactly 3 applications are not accepted. So we need to find Px equals to 3. So just substitute in the formula. So 7C3 means from 7 applicants, 3 applicants are not accepted. So our probability is 0.2903. Okay, whereas for B, at least 2 applications are not accepted. So at least, so it need to be greater than or equal. So Px greater than or equal to 2. So which means that what are the values of x that can be included here? So of course 2, 3, 4, 5, 6 until 7. Okay, until 7. So we need to add up when Px equals to 2, Px equals to 3, Px equals to 4, Px equals to 5, Px equals to 6, Px equals to 7, in which it will be long calculation kan? So we need to be wiser. Okay, we need to be wiser. So what are the numbers that not included in this range? Of course, we know that, since the range is 2 to 7, so the number that not included in this range, of course, would be 0 and 1. So, we use the complement one. So, 1 minus P x equals to 0 minus P x equals to 1. Because x equals to 0 and x equals to 1 is not included in the range when x greater than or equals to 2. So we know that all the total of the probability, okay, the total for all of the outcomes should be 1. So 1 minus P x equals to 0 and minus P x equals to 1. So we will have 0.8414. Can you follow? I hope you can follow, you can understand. It's quite easy, right? Okay. Okay, let's move on. Value of mean, variance, and standard deviation for a binomial distribution. Okay, so mean in binomial distribution represent NP. Variance, the product of NPQ. And the standard deviation is the square root for the product of NPQ, in which N is number of trials, P probability of success in a trial, and Q probability of failure in a trial. Okay, next. Let's look at an example. A test has 50 multiple choice questions. So 50 multiple choice. So we know that, this is N. With 5 different options of answers for each question. Given that there is only one right answer for each question and the answer to each question are done by guessing, find the mean of right answer. Find the standard deviation of right answer. Okay, so we know that we have 5 choices for each question and the probability of getting right only 1. So the probability of getting right is actually 1/5. Okay. Okay. Next. So, okay, we list up. Okay, probability of getting right answer. Okay, actually 1/5 because we have only one right answer from these 5 choices. Okay, and then Q, probability of not getting the right answer. So of course Q is equals to 4/5, in which 0.8. So, okay, we know this is binomial. Okay, so A, the mean of the right answer. Okay, mean is equals to the product of NP tadi. So we multiply 50 with 0.2, so we have 10. However, when we talk about standard deviation tadi, okay, tadi mean tadi apa? Mean NP. Standard deviation is the square root of NPQ. Okay, square root of NPQ. So we have the value of N, we have the value of P and Q, so just substitute in the formula. So we will have the standard deviation is 2.8284. Easy, right? So this is a simple question, the basic one, the simplest one, okay? Okay, next, example 4. X is a binomial random variable such that X is binomial, okay, NP, okay, N and P we didn't know. If its mean and standard deviation are 60 and 3 set 5 respectively, find the value of P. So remember, mean is 60 and standard deviation 3 set 5. Mean, the formula is NP, and standard deviation, the formula is square root of NPQ. So let's look. Okay, this is our information that we should know. Okay, next. Okay, from here, mean is 60 and mean is of course NP. So we can say that, NP is equals to 60. Okay, so from the standard deviation formula, we said that standard deviation is the square root of product of NPQ, in which from the information given, we know that NP is 60, so I just substitute 60 represent NP here, and from the question also state that the standard deviation is 3 set 5. So we can conclude that square root of 60Q is equals to 3 set 5. So from there we can find our Q. So when we have the value of Q, of course we can find our P, in which P is actually 1 minus Q. So we have P is 0.25. So P settle. We have our value of P. So how can we find N? So N, the simplest way is by using the mean formula. Mean is equals to NP. So NP is equals to 60. So P, we have known that P is 0.25. Therefore, our N is equals to 240. So N 240 and P 0.25. Easy, right? This is easier compared to probability before. Okay, let's look at solving problem questions. Okay, example 5. Encik Fauzi, the counsellor of Sekolah Menengah Damai, notices that 25% of the SPM school leaver of his school will not pursue higher education. A random of 12 SPM school leaver, so we said that N is equals to 12, is chosen. Calculate the probability that at most in Malay, at most 2 of them will not pursue higher education. At most 2 of them will not pursue higher education. When we talk about at most, if we translate in BM, in Bahasa Melayu, at most is paling banyak. Or in other words, maximum must be 2. Maximum. So, what is the inequalities involved? So, when we talk about at most, so the number should be paling banyak ni. Tak boleh lebih. The maximum must be 2. Cannot be higher than that. So, the number involved in this range must be less than or equal. So, we said that it must be less than or equal to 2. Understand? Okay. So, how can we find the probability of this one? So, first of all, macam biasa, define. X is the number of school leaver who will not pursue higher education. And N is the number of school leaver chosen, which is 12. P, probability of not pursuing higher education, in which in this case, 25% represents 0.25. And Q is the probability of pursuing higher education. So, our Q probability is 0.75. So, okay, since we are talking about finding the probability, so that is our formula. Okay, case 1. At most 2 did not pursue higher education. So it means that the person involved at most 2, of course, when x equals to 0, x equals to 1, x equals to 2, because we said that at most before is when x less than or equals to 2. So the number included is x equals to 0, x equals to 1, x equals to 2. So we add up all the probabilities. Therefore, we will have our probability for at most 2 did not pursue higher education is 0.3907. Okay. Contradiction with that, when we said that at most 2 did not pursue higher education, that means at least 8 students pursue higher education, right? So in contradiction, at least 8 students pursue higher education. So in which we are saying that when we talk about at least, it must be greater than or equals to 8. 8 pula 10, because we are talking about 12, 12 students and 10. So what number included in px greater than equals to 10? So we talk about when x equals to 10, x equals to 11, and x equals to 12. So nak katanya, we have other alternative method. Case 2, in which we said that at least 10 pursue higher education. So we need to find what is the probability for x greater than or equals to 10. So this is the solution. Oh, typo. This is 10. Okay. So as you can see, the answer will be the same. Okay, the answer will be the same because even though we have 2 cases, the meaning is still the same. Okay. Okay, example 6. On a particular day, the mean number of female members visiting a gymnasium is 5. Okay, so from here, we can say that, mean equals to 5. And the standard deviation is 2. Calculate the expected number of members who are visiting the gymnasium on a particular day. Expected number of members. So n is equals to what? This is actually what the question asks. Okay, so as usual, define x. So x is the number of members who are visiting the gymnasium on a particular day. Mean 5, so we write it as np equals to 5. Standard deviation 2, so square root of npq is equals to 2. Okay, next. Okay, this is binomial. Okay, so actually as we can see, we have 2 information in which this is equation 1 and this is equation 2. So how can we find the value of q based on these 2 equations? So the answer is we can divide equation 2 with equation 1. Okay, we can divide equation 2 with equation 1. So this is equation 2 divided by equation 1. So we will have npq over np equals to 4 over 5. So when we divide npq with np, we can only have q. So our q is 0.8. Okay, so we have our q. Next, of course, when we have the value of q, we will have our p. So our p will be 0.2. So now we do have p and q. So how can we find n? So In order for us to find n, of course, we need to substitute the value of p in min. Okay, because min is equal to np. So, since our np is 5, therefore n is equals to 25. Okay, simple kan? It is easy. You just need to understand the situation and use the formula that's involved. Okay, so we can say that there are 25 members visit the gymnasium on a particular day. Okay, simple. Okay, test yourself session. Okay, so I give you 2 questions. Okay, 2 questions. Actually, this question is from your textbook. Okay, so you need to discuss. You need to discuss the answer with your teacher. And of course, in improving yourself, in mastering this topic, of course, you need to do a lot of exercises. So this is my gift for you, homework for today's lesson. Okay, from textbook. Okay, please do these exercises, please. Okay, so last but not least, okay, before I end up my session, remember that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. Okay, and for you to get this essence, you need to do a lot of exercises. Only then you can see, oh, how you can learn on how to make complicated things. Okay, so before, that's all from me. I wish you all the best and good luck. I end up my session with Assalamualaikum warahmatullahi wabarakatuh and peace be upon you. Thanks.